Hello, everyone. Welcome to this live webcast about extreme weather. We're broadcasting today from the Ocean Sciences Center at the Aquarium of the Pacific in Long Beach, California. As you watch the presentation, you can send in any questions you might have. You can do it via Twitter at Aquarium Pacific and use the hashtag AOP Weather. Or you can send us an email to live@lbaop.org. The Aquarium has had a long-standing partnership with the National Oceanic and Atmospheric Administration. Together, we installed this Science on a Sphere facility that we will be using today, and we've had many joint projects together over the years. Here to discuss extreme weather and forecasting is Mark Jackson. Mark is the meteorologist-in-charge for NOAA's National Weather Service in Los Angeles and Oxnard. Mark?
Thank you very much, Jerry, and it's a pleasure to be here at the Aquarium of the Pacific. NOAA is a proud partner with the Aquarium of the Pacific in climate education and understanding climate, analyzing climate, and understanding what is happening to our climate and what might be happening in the future to our climate. And what we are seeing now within the last over half century is we are seeing an increase in extreme weather events. And compounding the issue is that our vulnerability has actually increased. We have moved to the coastal areas. Our communication systems, we've become very reliant on our communication systems and become vulnerable to the impact from these extreme weather events. The Science on a Sphere education tool represents a very important piece in our achieving our goal of climate education and educating the public and our partners on extreme weather events. And currently within the West, we are seeing one extreme event, which is the drought. We are experiencing exceptional drought throughout most of California. Over half of California is considered the worst case scenario drought. And it's the kind of situation which we must understand will happen again in the future. We must be able to adapt to these situations. And not only the drought, but in other parts of the country, we can then experience at the same time heavy precipitation. And through all of the better understandings that we have, such as on the Science on a Sphere, and educating the public to understand that these events will happen, we have to adapt, we have to prepare, we have to be able to respond to these events when they happen. We are getting better at forecasting these events. The President of the United States just announced yesterday an initiative which includes NOAA in producing new long-range outlooks for extreme weather events, and starting immediately actually with a new product which will provide probabilities of extreme weather events over the next 3 weeks or so. And so this is an important step to be able to predict these events, to be able to be prepared for these events, because we can adapt to them and we can become resilient to these events. Thank you.
Thank you, Mark. Now I would like to introduce Glen McDonald. Glen is a professor of geography, ecology, and evolutionary biology at UCLA. And Glen is going to discuss the extreme drought conditions from a historical perspective and also for future prospects. Glen?
Thank you very much, Jerry. It's always a pleasure to be here, and I and UCLA are proud to partner with you on your very, very many exciting initiatives here at the Aquarium of the Pacific. I want to talk a little bit about the extreme drought that we're experiencing here in California right now. I want to look at why we are so vulnerable to this one, and I also want to look at what it bodes to us for the future. If we were to look at the precipitation for the current drought, we would find that it is not. Our winter precipitation has not been that unusual. It's low, but over the past 100 years or so of historical climate records, we've had winters as dry as it is this past winter. We've had runs of years that have been about as dry as it has been these past years. So in terms of precipitation alone for the state of California, this is extreme, but it is not a record breaker over the historical period. However, if we take a look at temperatures, and this is what really is making us more vulnerable to these years of low precipitation, We are in a period where we are experiencing an extreme long-term trend of high average annual temperatures. These are the winter temperatures that you can see on the graph. And you can see that we have a very high temperatures. In fact, 2014 is looking like it's going to be a record breaker here for the state of California. But this comes in a run of actually decades of prolonged high temperatures in the state. Now, you put these two things together in Palmer Drought Severity Index, which puts temperature and precipitation together. That's where we have the record breaker, and that's where our vulnerability is coming from. The high temperatures we're experiencing, high evaporation rates, they exacerbate the drought. And for Palmer Drought Severity Index, this year we are off the charts in terms of the severity of this drought, and this is why we're having the problems we are. If we then look at this in a broader perspective, for the first decade or so of the 21st century, Western North America, particularly the Southwest and California, has experienced generally dry conditions. This is not a one-off. These high temperatures are producing for us something we refer to as the early 21st century drought. If we then are to look forward again, look a little bit at a different perspective of this, and we look at our storage capacity. We utilize storage capacity in reservoirs to get through droughts. Many California reservoirs are now at about 50% of the amount of water they should have at this time of year. Some are quite a bit lower than that. For Southern California, our big storage, Lake Mead, Colorado River. At this point, we're at about 39% of its capacity. We are roughly 6 feet away in the elevation of Lake Mead from declaring a first-level water shortage declaration, which would mean an automatic 4.4% cut in water deliveries to the 3 lower Great Basin states in Mexico. So our storage capacity has been sorely challenged by this drought. The vulnerability is clear. May I have the next slide, please? Now, how about over the longer term? How about over thousands of years of records? Well, from tree rings in California, we can reconstruct Palmer Drought Severity Index going back in the past 1,000 years or even more. And what we find is that this is not that unusual when we take a 1,000-year record. The state has experienced dry conditions, Palmer Drought severity like this in the past, even without anthropogenic greenhouse gases. This is a vulnerability we have in the state that we must prepare for. It could occur naturally, but today it's exacerbated. Our vulnerability has been increased by increasing temperatures. That will go forward into the next century. That will continue as temperatures rise. Our vulnerability to low precipitation is going to increase. How long could a drought like this last? Well, if we go back to the medieval period, some 1,000 years ago, we had a drought caused by natural warming of the earth, that in the 12th century persisted across California, the Southwest, the Colorado River Basin for 50 years. Does this drought have to end this year? There's no reason that it has to end this year. We have had mega droughts that have extended not just years, but multiple decades. This might be a boding of what we are going to see in the 21st century. Thank you, Jerry.
Thank you, Glenn. Thank you, Glenn. And it's also exacerbated not only by increases in temperature, but increases in population. And there's no area of the country or of the world that's immune to extreme weather and effects of extreme weather-related events. And while we've had these in the past, many scientists believe that extreme weather events are increasing in frequency, intensity, and duration. But even if they're not, the losses of human life and property require that we do more to adapt to the impacts of extreme weather in the short term, and that we mitigate, that is, we reduce the driving forces of extreme weather events over the longer term. These actions are essential if we're going to reduce the vulnerability of communities and society to extreme weather events. For all or nearly all extreme weather events, there is some warning thanks to improved forecasts. You've heard from Mark Jackson. Every year these forecasts get more accurate and they extend over longer periods of time. And as Mark mentioned, earlier this week at the Climate Summit, the President mentioned a new program that's going to be led by NOAA, and the goal is to extend the forecast from what it now is up to 14 days to up to 30 days. But we also have to keep in mind that improved forecasts and longer warning times are of little value unless they are heeded. And this is an area where we will benefit from further collaboration of social scientists and communicators with climate science. This aquarium is committed to exploring these issues, to raise community awareness, and to help make our communities more resilient. Science on a Sphere is one good vehicle for doing this. There are more than 100 of these units around the world, and more than 50 million people visit those institutions every year. And every program that is developed for Science on a Sphere is made available to the entire network at no cost. And this experience on extreme weather is no exception. Now we want to see a very short statement from Dr. Alexander Sandy McDonald. Sandy is the Chief Science Advisor for NOAA's Office of Oceanic and Atmospheric Research, and he's Director of the Earth System Research Laboratory in Boulder. He's also the inventor of this Science on a Sphere. He did it, like many entrepreneurs, innovators, in his garage on a weekend when he was trying to explain global phenomena to his kids, and he was using a beach ball and a couple of projectors, and now we have this quite remarkable facility.
When people experience extreme weather, all they know is what happened to them. But it's in the whole world. And when NOAA came up with the idea of Science on a Sphere, they realized the complexity of the whole world and that it would allow us to see how the weather fits with the rest of the world. It also allows us to look at things we can't see, like what's happening in the oceans and the future of climate.
We've also learned a lot about how to build structures that are more resilient and about areas that are particularly vulnerable to some extreme weather-related events, such as storm surges, flooding, and wildfires. But often we are slow to incorporate this knowledge into building codes or into zoning regulations. We now have the opportunity to answer a few questions that may have come in. Claire, do we have any questions?
We've seen high temperatures recently. What's the forecast for the coming weeks?
We've seen high forecasts for the coming weeks. Mark, that one should be right in your bailiwick.
Well, season forecast out for 3 months. Typically, the Climate Prediction Center issues forecasts of precipitation and temperature anomalies out to 3 months. And currently, the pattern which is in place now and the prospects for the winter is for a weak El Nino. Now, there's a 65% chance officially of an El Nino. Now, when we do have a weak El Nino, unfortunately, there isn't a whole lot of correlation between weak El Ninos and precipitation anomalies in Southern California. So the current forecast, though, hedges that we will have a weak El Nino, which states that we will likely have about an equal chance of above normal or below normal temperatures for the coming weeks. But as we have this very strong upper level ridge over the eastern Pacific, which tends to dominate much of our weather, at least for the next week or so, it looks as though that we're going to have some fluctuations of normal to maybe just above normal temperatures.
What can people do to help reduce vulnerability and to save water? I think, Glenn, that's a good one for you. What can individuals do?
Well, when we look at the state water use, we see that about 80% is used for agriculture, about 20% in the cities. And 20% is an important number. There's a lot of things that we can do as homeowners to help with this issue. And most of the water we use is not for those long showers or for cooking or anything like that. It's in our gardens. And in the Southern California, 50 to 70% of water is used in our gardens. So something that we can do is look at using native landscaping, a little bit more drought-tolerant and drought-friendly plants. And we could really make a large contribution simply by our landscaping, having beautiful gardens and things like that. Use our indoor water, and then allow water to be used for agriculture to grow the food that we eat. So that's something I think we can all do. We can take a look at our garden and say, how can we make this beautiful and also make it water friendly?
And with agriculture is the largest single user of water in the state. It accounts for probably 80% of all the water. But we have a very important agricultural economy, 3 times the number 2 economy, which is Texas. I think many people, though, believe that we could use different ways of irrigation and crop selection where we wouldn't lose our important agricultural economy and still reduce water use. Would you like to comment on that, Glenn?
Well, this is an interesting question because agriculturalists tell me that for a lot of crops right now, if we were to decrease irrigation, we could have 2 issues. One is that yields will go down. They're pretty finely tuned in a lot, not all, but a lot of farms. And secondly, you do have a problem with soil salinity sometimes. So sometimes the practices we see in the field that may seem water wasteful, they actually are maintaining the sustainability of those fields. The question is, are we growing the right crops, though? Because some crops demand more water than others, and the farmers are driven by 2 things. One is economics and, of course, federal crop subsidies. And we might look at that, and as consumers, we might look at, are we buying water-friendly produce? Is it produce that was produced in a efficient manner? We might take a look at that.
And even without reducing the amount of irrigation, the way that you irrigate sometimes can reduce evaporative losses. We got time for one more, I think. All right. The percent hurricanes, tropical storms affected in Southern California. Mark, what can we expect here in Southern California? Look into your crystal ball and tell us.
Okay. Well, I snuck a look at that question. I tried to look on the latest tropical outlook, I have to admit. But we have had a whole number of tropical storms within the eastern Pacific. And if you look at the sea surface temperatures, which hurricanes feed off of that energy of very warm water, we do have above normal temperatures throughout in the eastern Pacific and extending up in the Baja. We had Hurricane Odile, which moved up into the Baja and then up through the Sea of Cortez. That actually fed off of waters that were in the 90s degree Fahrenheit, so very warm water. So as we look out over the next several weeks, our hurricane season within the eastern Pacific ends on November 1st. So we are getting into the tail end, at least, of some tropical activity. But as long as those waters stay warm within the eastern Pacific, then there is a greater likelihood of at least some further tropical activity developing.
Thank you, Mark. We want to thank all of you for sending in your questions. And if we didn't answer them live, we will answer them online after this broadcast ends. Today, we're very proud to debut the Aquarium's new extreme weather show for Science on a Sphere. The public can also experience this show today at the Oregon Museum of Science and Technology, Science and Industry, in Portland, Oregon, at the Grand Canyon National Park in Arizona, and at NOAA headquarters in Silver Spring, Maryland. Funding for this experience came from the Miller Foundation. We thank NOAA and Sandy McDonald, and we thank our speakers, Mark Jackson and Glen McDonald, for lending their expertise to our presentation this morning. And I want to give a tip of the hat to our remarkable in-house AV department. They did a remarkable job, I think, of creating this, led by Derek Basile, the manager of our AV and IT units. Keith Miller did the animations, and Andrew Cohen had the overall lead in story development. And Mark Jackson and Gary Grimm were with us every step of the way in the development of the story and in selecting images to illustrate this. And you heard earlier about El Nino. Well, the next one of these experiences will be on El Ninos, and it will be ready to be launched some in a month or a month and a half. So with that, we conclude today's live webcast. We thank you for joining us. A video of this webcast will be archived on the Aquarium's website at aquariumofpacific.org. And now we're going to have a screening of this new extreme weather Science on a Sphere experience. And following that, our experts will be available for interviews with any of you. Thank you. Derek?